Failure mode and effects analysis, FMEA, is a systematic, proactive method for evaluating a process to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts of the process that are most in need of change. The methodology is used to determine the chance of a specific failure happening and its impact on other sub-items or systems, as well as to identify actions that can mitigate that risk. The origins of failure mode and effects analysis, FMEA, date back to the 1940s when the US military developed procedures to determine failure effects as a part of their ammunition and rocket development. Now, in the 1960s, the method was further expanded and refined by the aerospace industry, which faced complex challenges in systems and reliability. Over the years, failure mode and effects analysis became widely adopted in industries such as automotive, electronics, and more due to its effective approach to risk management. The following are some of the importance and benefits of failure mode and effects analysis. First, risk identification and mitigation. And failure mode and effects analysis helps in identifying potential failures in a system or product design and suggesting measures to prevent or reduce their impact. Second, cost savings. By proactively identifying failures, organizations can save considerable costs that would have been incurred due to system downtime, warranty claims, or potential litigations from failing systems. Third, improving quality and reliability. Failure mode and effects analysis enhances product quality by identifying weak spots and areas of improvement in design and process. Fourth, customer satisfaction. By reducing potential failures, manufacturers can provide a more reliable and high-quality product to their customers. Basic principles of failure mode and effects analysis. The following are some of the basic principles upon which failure mode and effects analysis is based. First, systematic and structured analysis. Failure mode and effects analysis is a step-by-step approach to identify all possible failures in a design or process. Second, team-based. Failure mode and effects analysis is most effective when it involves a cross-functional team that brings in diverse expertise to understand a product or process potential failures. Third, documented. One of the goals of an effective failure mode and effects analysis is to document potential failures and recommended actions, ensuring that there is a record of the analysis and decisions taken. Fourth, iterative. As changes are made to rectify potential failures, the failure mode and effects analysis should be revisited to ensure that the changes haven't introduced new problems. Objectives of failure mode and effects analysis. Objectives of failure mode and effects analysis. The following are some of the aims and objectives of failure mode and effects analysis. The first is identification of potential failure modes. Identification of potential failure modes. This involves understanding how a product or process might fail. Understanding how a product or process might fail. Second, determining the effects of failures. Determining the effects of failures. This involves recognizing the impact of these failures on the customer or the next operation. Recognizing the impact of these failures on the customer or the next operation. Third, prioritizing failure modes. Prioritizing failure modes. This involves using the risk priority number RPN, which is calculated based on 3 criteria, which are severity, occurrence, and detection. Fourth, driving improvements. Driving improvements. By focusing on high priority RPNs, high priority numbers, organizations can make effective use of their resources to drive meaningful improvements. The fifth is documentation. Documentation. This involves keeping a record for future references and learning.